I'm Ruben, and I'm about to log into Mandarin Coach, a personal error intelligence agent for self-directed Mandarin learners. So here's the problem. If you're like me, you've reached an intermediate level of Mandarin, and you keep repeating the same mistakes, grammar mistakes, month after month, and these areas are kind of stopping you from talking to native speakers and really breaking past that intermediate plateau that you reach. So I'm using quite a few tools at the moment. I've got Duolingo on the go, Anki cards, a weekly tutor, but these are snapshots, and in these classes and apps, I'm doing a lot of exercises, and they might correct the exercise, but they're not really capturing what I'm doing wrong and if I'm doing it consistently. So this app is here to address this. So let's log in as a new user. You can see I just logged in, and we get given a prompt of whether or not what HSK level we are. You can select which one you think you are, and that's stored against your user information. And so with that, there's an expectation that you should know X amount of words and X amount of grammar. So as a beginner, you probably should know 300 words and probably a dozen grammar patterns. And so that's saved against the corpus. But let's look at my profile in particular, because that's the one I've been playing with a lot. Let's do kind of a pretty common error that I run across is measure words. So here I've written 我看三个数, so help me with this. Is the measure word correct? So in China, Chinese is actually quite a lot of measure words. There's not just, oh, you just count and then that's it. Like, oh, there's one dog, there's one cat. It's like usually there's a word in there that kind of gives the measure of it. So we could see the agent run, cool tools. I've just kept this in here just for demonstration purposes. We can see it calling an error pattern analyzer because it's picking up on our error. We're picking up on the grammar rule that should be looked at, and then it's also doing a dictionary lookup to make sure that the Mandarin it does return to you is correct. So you can see we get an explanation, a correction, and then maybe a bit of a quick drill to actually fix our problem. On top of that, the error is actually saved to our corpus against the user, so your errors are actually tracked, and then you can actually begin to see where you improve. So maybe another quick question is, what are my most common errors? And here we can see the agent thinking. It will use the tool error pattern analyzer again, and there you have it. Because I've been using this application quite a bit, we can see I've done 5 grammar errors, 2 word order errors, because word order is very important, but that's slightly decreasing across our conversations. And then the measure word error, which I just showed you before, well, that's increasing to 2. So a bit of an explanation, and then from here you can actually also go drill me and kind of practice those errors, which is also pretty cool. And here we've got a drill generator and an agent actually building an exercise for you to practice. But something else we can also see is the traces in Langsmith. So here you can see during my evals, there were 1,300 traces, and as I've been playing with this application recently after deploying it, there's 83 traces. I won't dive into them because it's a lot, but enough of that. Let's jump into the actual architecture of everything. So I'll quickly jump to the architecture diagram, which we have here. What you saw there was the Chainlet UI, quite simple. We've got a username, password, login. Then there's a bit of a in-session memory. We haven't stored the chats per se. That could be an enhancement. But we do have some sense of long-term memory in that we store the personal errors like I showed you, and these persist across sessions. On top of that, within the LangGraph agent, we've got a few tools. We've got the grammar rule fetcher. We've got the drill generator, which targets our common errors, and then we've got an error pattern analyzer, and you can see those to talk to the ChromaDB, where we store our grammar rules, which are embedded, our grammar patterns, our expected HSK vocabulary, as well as our error patterns. And then in terms of tracing and other tools available, we've got Tavily for web search, which is just a nice to have, and we've also got a Chinese dictionary lookup to make sure we get that opinion and correct characters. And for now, what I've built this application on, and I'll show you where we did head-to-head against a few different models, and I landed on using DeepSeek V4 as a default, but there were some timeout issues that we ran into, and so as a fallback, if those timeout values are hit, well then we use GLM 5.2, which was our second better performing model. A very important part of building this agentic application was the evaluations. So our test set was designed around, I'd say, 3 different types. The first one was stateless, which is where there's just a single error. And what we did is we compared our agent against kind of naked LLM as a control arm. So the LLM won't have all the tools that our agent does, and so we can see here whether or not our application and our agent is actually worth having. And so in the stateless scenario test cases, we saw that there was pretty much parity between our agent and the control, which is kind of expected because, you know, you can go to a lot of LLMs these days and just go, what's wrong with this Chinese sentence? And you'll get a good answer. The second one was seeding things with about 5 errors, where there's a kind of a small personalization with a small amount of history. Again, there was quite similar parity because we were still only dealing with a small kind of set of errors, and you could probably get away with a lot of LLMs these days of just going, what's wrong with this, what's wrong with this, what's wrong, and, you know, back and forth 5 times, and it will still be able to answer things correctly and understand and kind of track your errors that way as well. And then lastly was a more at-scale scenario where we've got almost 50 to 100 different errors pasted into the conversation, and then we compare our agentic system with our control, and this is where we saw the core differentiation in our agent compared to just a control kind of raw naked LLM. And obviously that's a lot to do with the harness and tools that we give it. Quickly kind of jumping to the results around comparing our agent to kind of the control. You can see the numbers here. Where in the stateless scenarios we're very much on par, there's similar parity, and then as things begin to scale, that's when we see a little bit more differentiation because our LLM can, you know, access the ChromaDB that stores the user's information in areas because we track errors after each error pops up in a conversation. I guess another very important thing to point out across our surfaces and our metrics that we measured was that wherever we used LLM as a judge, we also made sure that there was a deterministic cross-check. And where they two kind of disagreed, we went with the deterministic result. This was important because we used GLM 5.2 as an LLM as a judge, and when we did that, it actually started, it was caught kind of logging errors with empty details, fields, incomplete records, and so we kind of had to add extra guards around that. So it's very important on the kind of model that you choose to be your judge. I'll just touch on a few of the improvements that we made on our application as we went along. We increased our grammar coverage by doing a little bit more research. We also had to add a lot of guarding and validation around things because there was a little bit of failure here and there. And then on top of that, when we looked at our different models, we ended up deciding on using DeepSeek as a final model, but if that times out, then it will fall back to GLM 5.2 in case things go wrong. Another interesting thing was actually the retrieval results for our vector database when we look for error patterns and so on. And coincidentally, hybrid was the best approach with BM25 and dense retrieval. And I thought this would be the case just because Chinese characters are very specific, and so by having BM25 in there, like a single character can be a single word in a single match, and so it's very easy to retrieve get good retrieval results that way in the hybrid approach. And continuing on, our model bake-off that we did, in actual fact, Gwen 3.5 was pretty poor at times and would actually just give out garbage, so it was completely dropped. And there's our final decision. Yeah. So all in all, there's a few other features to add, but as they like to say in Chinese, xie xie.